Welcome students to this series of lectures on statistics. And in this series of lectures of statistics, we are within this series in a series of lectures on probability distribution. And in the probability distribution, we completed discrete probability distribution and entering into the continuous distribution. This is our second distribution in the space of continuous distribution. And today we're going to introduce normal distribution. If I want to highlight the importance of this lecture, then I should say that you should breathe in, breathe out normal distribution if you are a CFA or FRM aspirant or you're working in finance field. Because if you're not aware of normal distribution and you're assuming that you're a veteran of finance, then you're faking yourself or you don't actually know finance. Because in finance analytics, I'm not talking about the valuation, equity valuation profile. I'm not talking about equity valuation profile, but other profile which are related to finance analytics, where you have modeling, risk assessments, risk monitoring, or derivative valuation, hedging. You need in-depth understanding of normal distribution. And uh, with the experience of 10 years, I can say that very few people, only 20, 30 people in the finance domain actually understand in-depth normal distribution, even those who are working in the domain of financial analytics, and which is not good. So if you really, really want to be a good finance risk model developer or model validator, you should be pretty good in normal distribution. Now, the reason for saying that because normal distribution is everywhere. If I just talk about your curriculum, the CFA and FRM curriculum, first of all, you should be aware about normal distribution because you have to do certain prediction. If you want to predict stock return, you need to know that which kind of stock return is normally distributed. Is it arithmetic stock return which is normally distributed, or is it geometric one which is normally distributed? So you need to know that which distribution, which entity is normally distributed. So this is number one. The second is it is heavily used as you complete probability distribution, the complete lectures of probability distribution, you would enter into hypothesis testing because you have to test your prediction. So hypothesis testing, it cannot be studied without in-depth understanding of normal distribution. When you enter into regression, the regression assumptions start with normal distribution. If you talk about derivative valuation, Black-Scholes-Merton model has ND1 and ND2. What it is? It refers to what normal distribution, value at risk, expected shortfall, whatever you say, it all depends upon normal distribution. Without in-depth understanding of normal distribution, you cannot succeed in CFA or FRM examination, or you cannot succeed as an financial analyst, as in the people who develop risk models or valuation models based on regression or whatever, right? Because any basic model which is being developed in any one of the good organization, good team, it is based on what? Simple linear regression. The basic is simple linear regression. You don't know normal distribution. How would you know simple linear regression? So I'm trying to emphasize that because it's critical. It's critical, and that's why I said that you should breathe in, breathe out normal distribution if you are appearing for CFFRM or CQF. And even if you're appearing for any examination where we have statistics, so definitely you should be pretty good with normal distribution. So if you're appearing for actuaries, you should be pretty good with normal distribution. Now, how to study normal distribution? So take easy steps. The first step should be understanding the different properties of normal distribution. Start with property, which is easy, simple. We'll try to cover properties in this lecture only. I'll try to cover properties in this lecture only. The second thing is why and when. See, why and when is associated. If you know why normal distribution is in this world, right? It is $1 trillion equation, right? And we created a video on this, a $1 trillion equation. And the irony is that that was our first video on this channel. The $1 trillion equation is the equation which is related to what? Normal distribution. It is so important. So if you understand normal distribution, why to use normal distribution, you would know when to use normal distribution, why normal distribution came into place. If you understand that, we all know the reason behind that is what? Central limit theorem. So in the next lecture, we'll study the central limit theorem, the CLT theorem. And the last is prediction, right? You have to do prediction, whether you develop model through regression to predict or whether you want to predict and then want to test through hypothesis testing. You need to know whether that first entity is normally distributed or not. Not every entity in this world is normally distributed. There are certain condition has to be followed, then only it can be normally distributed. So you cannot do the prediction based on normal distribution assumption every time. So if an entity is normally distributed, you can easily do the prediction, but even you can test that prediction with the help of normal distribution in the hypothesis testing, or you can perform regression based model to do the prediction. So these are the three steps to study normal distribution. First is properties. You understand the properties. Second, why. Why is related to central limit theorem, and then prediction. Okay. Now, if you've never heard or studied normal distribution, then you must have heard something called as bell curve. But please note that not every bell curve shaped distribution is normally distributed. That's not true, because even t distribution, which you will study in one of the lecture, is also bell curve, but that is not normal distributed curve. That is t distribution, right? That is another distribution. The other distribution which feels like bell curve, but it's not normally distributed. So you need to know that what are the properties that has to be satisfied, and then you can say, okay, this particular curve is normally distributed curve. It is not that every bell curve is normally distributed. You might have heard, if you're working, most of your HR would be saying that, okay, your rating is decided based on bell curve. Your bonuses and salaries are decided based on bell curve. But if you ask them about what is bell curve, they will not answer. And that is not expected from HR, because they would not study statistics. But what is that? So they're talking about how normal distribution is so important in decision making. So even normal distribution is used in decision making in a very intuitive way, maybe not exactly a statistic way. So that's why normal distribution is the most important distribution you will ever study in your life. Okay. So coming to the properties, and the properties are very simple, straightforward. You don't have to worry about that. What are the properties? Is it going to be very complex? No, very simple, because normal distribution is a very simple, universal, found distribution. You will find this distribution everywhere. So the properties are pretty simple. The first and the second properties are related, A and B. Mean is equal to median is equal to mode, right? We are talking about moment one, but do you remember where we discussed mean is equal to mode, or mean is equal to median is equal to mode? When we discussed moment three, asymmetricity in the data. If the data is symmetric, the skewness is zero. You remember the lectures of moment three, skewness. So the data, if the data is symmetric, then mean is equal to median is equal to mode, and the skewness is going to be zero. So in this distribution, if this is the line which bisects the data into two equal half, which is the median, then this point is mean, this point is median, and this point is mode. And if you see the left section and the right section, they are going to be mirror image, identical mirror image. Okay. And if they are identical, then the data is what? Symmetric. The curve is symmetric because you can bisect the curve from the half, and both the half are mirror image. So the data is what? Symmetric. It's not asymmetric, right? If there is symmetricity in the data, if there is symmetricity in the data, then what is the skewness of the data? Zero. There is no asymmetricity in the data, because skewness is the measure of what? Asymmetricity in the data. So skewness is zero. Now you see that the third property is kurtosis equal to 3. Now, this is important. Now, when you see t distribution, the shape of the t distribution is somewhere near to this. The only way to differentiate between t distribution and normal distribution is to study kurtosis. Any entity which is following normal distribution will come to 3. But in t distribution, which feels like normal distribution, looks like normal distribution, the kurtosis is greater than 3. They have what? Fatter tails. What is kurtosis? Kurtosis is a measure to identify the fatness or thinness in the tail. Okay, so what is the fatness or the thinness in the tail of normal distribution? It's 3. We call normal distribution to be a mesokurtic distribution. We discussed this in kurtosis, right? What is force property? The total area under the curve is going to be 1. It's not only true for normal distribution, it is true for any continuous distribution in this space. If you remember uniform continuous distribution, we said area under the curve is equal to 1. Here, area under the curve, the whole area If you try to plot the whole area, this whole area is going to be what? 1, because that represent the total probability, and total probability has to be equal to 1, right? 100%. So total probability is 1 or total area is 1. That is the fourth property. What is fifth property? Asymptotic tail. See, if you see this, then in right direction and left direction, both the direction, the x-axis is approaching infinity. Okay, infinity and minus infinity. Let's write it down, minus infinity or infinity. And the normal distribution tail, this tail, is trying to touch x-axis, which means it's trying to touch x-axis, or it is trying to approach infinity, but will never touch x-axis or will never approach infinity in both the direction. So that is the meaning of asymptotic. They try to touch but will never touch. Any two line which is trying to touch but will never touch till infinity. That is asymptotic behavior. So that is the asymptotic behavior of the tail of normal distribution. Last property. Parameters are only two, that is mean and standard deviation. If you want to do any prediction of an entity which is normally distributed, you only need to know mean and standard deviation of the entity. That's it. You only need mean and the standard deviation, mu and sigma. If you know mu and sigma, mean and standard deviation, you would be able to do any prediction about the entity if the entity is normally distributed. Okay, so only two parameters are required. The last, the last is the probability density function. The probability density function of normal distribution is 1 upon sigma root 2 pi e to the power, e is Euler constant. We used Euler constant in where? So we used Euler constant in Poisson distribution. E raised to the power x minus mu square upon 2 sigma square. This is the probability density function. So there is a complete video dedicated in this channel for this probability density function, that why this equation is the equation of normal distribution. Okay. So 1 upon sigma under root 2 pi e to the power minus x minus mu raised to the power 2 upon 2 sigma square. Okay. So please watch this video, which would be the next video in this series, and this video is already uploaded in this channel. So watch this video. The video name is the $1 trillion equation, and you will understand why the normal distribution has this particular probability density function. Okay, so we'll pause here. We have just covered the properties of normal distribution. The next session is very critical, because there you will understand that why normal distribution is a universal distribution, why you will find normal distribution everywhere in the world, and when to apply normal distribution and when not to apply normal distribution, which is the second lecture. So with that, we'll pause here. Thank you. Have a nice day.